Oh, okay. Assalamu alaikum. Am I audible?
Walaikum Assalam, yes you are.
Right. So I have shared a link about the Zoom invitation link, right? So that is for accessing this OneNote page, right? Can you just check if you are able to access the page from the link?
Okay, give me 1 second. I'm opening it up. Is it the okay? Wait, yeah. Let me check this one. Yes, I can access it.
Okay. So is everything visible?
I believe so. I'm opening module 7. Let's see. Yes,
Are you able
everything.
to collaborate?
Let me see. Oh, right. Let me just write something here.
So the entire note can be shared with you, right? So if you have any questions regarding the previous chapters, you can just go and see them, right?
Yeah,
Okay. Okay. So when will your exam happen?
that's right. Oh wait, give me 1 second. If number 2. I'm just gonna type something. Can you see this?
Uh, no. Actually, during the class, we don't want to collaborate. I will be updating everything. After
Oh,
finishing the class, you should be able to access the note, right? That's the purpose of sharing.
okay.
Okay, okay. If you want to write anything during the session, you can use Zoom annotation option, right?
Yeah, okay.
And after finishing the class, while you are studying, if you want to mark anything, you can use that notebook also, right?
Okay.
Okay. Okay. So when will your exam happen? The sixth
It will
term,
be on the 10th of April.
10th of April. 10th of
Yes.
April, and this is going to be the sixth term, yeah?
Yes.
Okay, sixth term means the questions will be coming from the chapter 6.
I believe so, yes.
Okay, so we have already completed chapter 6, yeah?
Yeah.
Uh, okay, so should we revise chapter 6 or shall we continue chapter 7?
I think we can continue chapter 7 and
Okay.
then probably on our lesson on the 30th, can we revise chapter 6?
I'm sorry?
Is that okay? Or, I think we can continue with module 7
Mm-hmm.
this week and next week,
Mm-hmm.
but the following week we can revise chapter
Okay.
6
Before
in
your
module.
exam, we can. Yeah, we can.
Yeah.
Yeah, okay, that's fine. So we have initiated the organic reagents used in organic reactions, right? So I read your feedback message. You have, mentioned that I shouldn't go beyond your curriculum. Actually, that's okay. I have to accept that one because you have to study a lot of things. But the problem is I don't have the access to your curriculum, right? So
Yeah.
that's the issue. I don't know what I have to teach you, right? But these are
Mm.
basic things. I'm teaching the basic things. And since your ambition is to become a doctor, you should have the strong foundation in organic chemistry, right? Because
Okay.
all the
Yeah.
medicines are liberated using organic reagents. I mean,
Mm.
through okay, the medicines are synthesized using organic mechanisms, right? So this is
Yeah.
kind of foundation, and from here we have to lay the foundation very strong enough. Then only you will be able to thrive in the university as well, right? Otherwise, it
Mm.
will be a bit difficult, right? After that, again, can you come back to A levels and study the things? No, right? So here you have to lay the
Yeah.
foundation. Okay, and don't think that. And I always tell that we shouldn't try to confine our knowledge to the curriculum. We have to explore
Yeah.
beyond the curriculum as well, right?
Mm.
Because
Mm-hmm.
our ultimate target should be to acquire knowledge, right? So okay, now I don't know if I have already told you. Let me just remind, right? Because for believers,
Yeah.
reminding is very vital. Okay, so let's consider. Yeah. Wait. Okay, so let's say this is our life, right? So life is very big, right? So let's say this is our life, and examinations are just part of life, right? So when we are
Yeah.
studying, the intention is very important. As Muslims, for every worship or for every act, we have to set a good intention, right? So before we
Yeah.
begin any worship, maybe even before sleeping, we have to set an intention, right? Okay, so even studying is a kind of worship, right? So before we
Yeah.
study, we have to set an intention, and that intention should be to acquire knowledge, right? Or the
Mm-hmm.
education should be beneficial, you know. We have to ask Allah to provide beneficial knowledge. Beneficial knowledge means what?
Information that
Yeah,
we
what is
can
beneficial knowledge?
utilize.
Now, for example, if you study about Quran, that is beneficial and eternal, right? That will be helpful
Mm.
even after your death. But
Yeah.
these worldly education will not come to you after death. This is just for surviving during the what do you call, during the, you know, until you die, right? Until you die, you have to
Yeah.
secure a job, and for that, education is very important, right? So till you die, you have to remember all these, right? So you have to set that kind of intention, right? So now I'm just telling all these things because you requested me to teach only the things in your syllabus, right? So
Yeah.
if your intention is so, then you are focusing only on the examination, right?
Mm.
Now, for example,
Yeah.
let's say uh, sometimes, okay, for example, in our in our primary grades, we have studied the numbers, alphabets, right? So
Yeah.
so those things are still needed.
Yeah.
Right? Similarly, the things
Mm-hmm.
that you study now will be useful in future also, right? But many people
Yeah.
in university also, they are unable to survive in the university because what's the reason? During A levels, or you are now in A levels, right? So during the
Yeah.
A levels, they are studying only for writing the A level examination, right? So after writing the A level examination, what will happen? You will forget, right? Because you
Yeah.
have programmed your brain to remember the things that you studied only till the examination is over, right?
Mm.
But
Yeah.
when you are studying, like, okay, now I am studying this, and you have to have this intention all the time. My ambition is to become a doctor, right? So when I become a doctor, definitely these things will be needed. So when you have that intention while you are studying, right, examination can be
Mm-hmm.
passed because that's just a part of life, right? So
Yeah.
every time you attend the session, you have to have this kind of intention. I have to
Okay.
study something new. I shouldn't study only for the examination. I have to study
Mm.
something beneficial for my future, right?
Yeah.
Okay, right. So with that note, we are going to start the remaining things, right? I told you about this is the list, right? So first we looked at Tollens reagent, and then we looked at ammonia and CuCl2, and then Feeling solution. Did we study Feeling solution?
I don't believe so.
Okay, so okay, Feeling solution, and then we will have to study Brady's reagent and Lucas reagent. After that, we have to study, these are very important things, right? So oxidizing tools and reducing tools, and then hydration tools, halogenation. So simply hydrogenation. I'm sorry. Hydration means we are going to add water. We are going to add water
Yes.
to an organic compound. Have you already studied? Are you currently studying organic chemistry in school?
Yes.
Okay, right.
Not in school. In my other class, yes.
Okay, okay. Right. So halogenation means we have to add halogens, right? Chlorine, bromine,
Yes.
iodine, and we have some more organic reagents, right? These are popular organic reagents. Okay. Yeah. So we will now begin with feeling solution, right? Mm, Let me insert a new page. Okay, so that would be our uh, third reagent, right? Right.
Yeah.
So reagent number 3, feeling solution. Feelings solution. Okay, so I am writing beautifully so that you can access, you can study later as well, right? So feeling solution chemical formula is ammonia CuCl2. Ammonia CuCl2, right? So this is, now we have CuCl2 and ammonia. This is a mixture, right? So this mixture is called feeling solution, right? So it undergoes oxidation, redox reaction, right? So the first point, undergoes redox reaction. Okay, right. And if you want to use feeling solution, now why do we use reagents, organic reagents? What's the purpose of using these organic reagents in organic chemistry? I already discussed when I taught you the previous reagents also.
Uh, uh, I don't remember.
Okay, for example, we've already discussed about functional groups, right? So let's say we have been
Yeah.
given a sample of organic compounds and we have to test if particular functional groups are present in the sample, right? For that, we have specific tests, right? For example, um, uh, first we studied tolerance reagent, right? So
Yeah.
if we want to check if aldehyde is present in the given sample, what we will use, we can simply use tolerance reagent. And what will be the observation? We will have silver mirror precipitation, right? So silver will deposit in its original color. So we can say in the given sample we have aldehyde, aldehyde group, right?
Yeah.
Okay. So similarly, if you want to use feeling solution, then this feeling solution will give positive result to aldehyde only, right? So will provide positive result uh, positive result or observation to aldehyde, right? Aldehyde. So aldehyde mean we should have C double bond OH, right? So there might be anything
Yeah.
here, it can be anything, right? And the observation, right? So let's say we have been given a sample, right? We don't know whether aldehyde is present or not. This is a sample, organic sample. What is this? Organic sample, right? Now we have to check if aldehyde is present. So to this sample, we will use ammonia CuCl2. So we will have a red color precipitate, right? Now if aldehyde is present, we will observe a red color precipitate, red PPT. So if we can witness a red color precipitate in the system, we can conclude that in the given sample, aldehyde is present. Okay, aldehyde is present. So
Okay.
we've already discussed this is
Okay.
going to be an redox reaction. It is going to be a, it's not moving.
Redox reaction. Yeah.
Give me a not moving. Yeah. Okay, so uh, we will explore the chemical reaction actually happening here, right? So the chemical reaction, let's
Okay.
consider a typical example, right? So we have CH3 C double bond H, right? And to this we
Yeah.
add ammonia and CuCl2. So here what should happen? This carbon, it is in the oxidation state of +1, right? And it should become
Okay.
+3. It should become +3, right? So when you administer this aldehyde with this Feeling solution, the oxidation state will be enhanced to +3, right? So which means it should
Yeah.
produce a kind of ester, right? It should produce a kind of ester, right? So CH3
Okay.
C double bond O minus, and now you see here this NH2. Now this NH3. Now what is happening here? Now this is aldehyde, right? So it should produce a kind of ester. So
Yeah.
this is an acidic
Okay.
hydrogen, so it can release this H plus, right? And this H plus will combine
And
with
then it'll
this
form
NH3 plus
NH4.
and produce NH4 plus.
Okay.
NH4 plus. Okay.
Cool.
Now this
Yeah.
NH4 plus will
Okay.
come and combine here. NH4 plus O minus NH4 plus, and here when this is oxidized, now you see here this is +3. The oxidation state of this compound is +3. So now you can observe -1 to +3. How do we call this process? Oxidation. Oxidation, right? Now here what is the oxidation state of copper in CuCl2?
It is 2 plus.
+2, right? Now this
Yeah.
+2 should be reduced to +1, right? And you should know
Yes.
copper oxide is red color, right? So in organic chemistry you should have studied Cu2O is a red color precipitate, and this is what we will observe, and this is what we told as the red color precipitate. This is what red color precipitate, right? So I'm drawing all these in green color, but I cannot change the color again and again. Okay, so that's why. Okay, so when you are writing your own note, you can use the exact colors so that you can remember with the color. Okay, so O minus NH4 plus. Now you see here the oxidation state of copper in CuCl2 is +2, right? Now what is the oxidation state of copper in Cu2O?
It is Cu2O. Is it +1?
It is +1, right? Now you see here +2 becomes +1. So this process is called reduction, right? So this is an redox reaction. Okay, so this is how it happens. Okay, so this is all about Feeling solution. So ultimately what you should remember is when you have aldehyde group in an organic compound, in order to detect it you can use Feeling solution. So Feeling solution is a combination of ammonia and CuCl2. And what will be the observation? We will have
A red precipitate.
we will have red color precipitate. Okay, so we shall watch some video. Give me a sec. Okay.
फेलिंग टेस्ट फॉर अल्डिहाइड. जर आपण अल्डिहाइडमध्ये फेलिंग
Are you
सोल्युशन
able to hear the voice also?
I can, but it's really like it
ए
keeps
ॲड केलं,
Okay,
all
let
the
me share
block.
the file
त्यानंतर
also. Oh.
त्यामध्ये फेलिंग सोल्युशन बी ॲड केलं तर ब्ल्यू कलरची प्रेसिपिटेट मिळते. हे सोल्युशन जर आपण बॉइलिंग वॉटरमध्ये ठेवलं तर रेड कलरची क्युप्रस ऑक्साईडची पीपीटी मिळते आणि अल्डिहाइड ग्रुप कन्फर्म. फेलिंग टेस्ट फॉर अल्डिहाइड. जर आपण अल्डिहाइडमध्ये फेलिंग सोल्युशन ए ॲड केलं त्यानंतर त्यामध्ये फेलिंग सोल्युशन बी ॲड केलं तर ब्ल्यू कलरची प्रेसिपिटेट मिळते. हे सोल्युशन जर आपण बॉइलिंग वॉटरमध्ये ठेवलं तर रेड कलरची क्युप्रस ऑक्साईडची पीपीटी मिळते आणि अल्डिहाइड ग्रुप कन्फर्म. फेलिंग टेस्ट फॉर अल्डिहाइड.
Now, did you study biology also? For testing carbohydrates also we can use feeling solution, right? I think
Okay.
the observation will be purple color or something. I'm not sure about that, but now okay, now you can see this one.
I knew I was underwater. I just didn't realize I was this underwater.
Now, feeling solution should be prepared by adding feelings A and feelings B, right? But ultimately, now initially it will give you the blue color, but ultimately it will produce a green, the red color precipitate, right? So I have generally told. Usually in chemical reactions, we are supposed to heat, right? So
Yeah.
why do we need to heat? Now, if you cannot witness the observation, the preferred observation, we cannot come to the conclusion that the assumed group is not present in the given sample, because sometimes the activation energy might be high, right? For that, for overcoming the activation energy, if you don't get the preferred observation, you better heat it, right? So what is the purpose of heating during a chemical experiment?
To increase the rate of reaction
Yeah.
by propelling a greater number or greater portion of the particles to have a
Simply you
activation
can say
energy.
by reducing the activation energy, we can make the reaction happen, right?
Hmm.
Okay, so now we have taken two test tubes, right? So here,
Yeah.
what can you conclude? Right. So in this test tube, you can observe a red color precipitate. And what is that red
Yeah.
color precipitate? That is Cu2O, right? So since you witness red color precipitate, you can conclude in this sample we have C double bond OH, but here we do not have C double bond OH. Sometimes other functional groups, right? Even this will not produce red color precipitate for carbonyl group. It should there should be aldehyde group only. Okay.
Okay.
Right, so you can see the red color precipitate, right?
Yeah.
Okay, so this is how we are going to. Now, do you go to laboratory?
Yes.
Do you perform all these experiments?
Not all of them, but we
හැමදාම හදන රොටි වලට B විටමින්
Oh, okay. So this is all about
පෝෂණය
feeling
එක්
sorry.
කරන්න මාමයිට් බ්‍රෙක්ෆාස්ට් පාර්ට්නර් කරගන්න.
Okay.
Okay, now we will move to the fourth reagent, right? So do you have any questions in feeling solution? Now feeling solution we have generally studied, but we can prepare feeling solution by mixing feeling A and feeling B also, right? And the prepared feeling solutions color will be blue color, right?
Okay.
Okay, so that is not actually required, but we have to know the ultimate observation only, right? But if you want to explore more, you can study what is feeling A, what is feeling B, and everything, right? So that depends on your interest. Now we will move to the next one. That will be, I think I have to add new pages, right? Okay, anyways, I will add a new page for now the next one, the fourth one will be Brady's. Oh. Fourth one, Brady's reagent. Okay, Brady's reagent. Did you study about Brady's reagent in the class?
No.
No, okay. So here Brady's reagent, there is a structure for it, right? And it contains benzene also. So let me draw the structure of Brady's reagent, and we are going to name it as well, right? So there will be a benzene, and here we have NO2 group, and here also we have NO2 group, and here we will have NH2, right? So simple structure, NH2, right? And the name of this one is 2,4 DNPH, dinitrophenylhydrazine. What is that? DNPH. We can simply use this name. So 2,4 dinitrile. Dinitrile means what? This is nitrile and this is also nitrile. And this is going to be our functional group, right? Phenylhydrazine. Phenylhydrazine is the name of this functional group, right? This is a complex one, right? So you don't want to actually worry about it. So you just remember the name 2,4 DNPH. What is the extended form? 2,4 dinitrophenylhydrazine, right? So this is nitro, this is also nitro, right? So let's say this is first, we have studied how to name the aromatic organic compounds also, yeah?
Okay.
Right. So this is 1, this is 2, this is 3, this is 4. So dinitro are there, but in 2,4 positions, right? So dinitrophenylhydrazine is the name of this one. Okay, 2,4 DNPH. Okay. Now this Brady's reagent can react with al and ketone, right? So it can react with al comma on, right? Okay, al comma
Yeah.
on. It can react only with al and on, right? So to distinguish between al and on, we cannot use Brady, right? For example, in a given solution, if you use Brady, you can say either al or on is present. Either al or on is present. But if you want to distinguish al and on, can you use this reagent?
Sorry, can you repeat it?
Okay, so in a given sample, okay, so you have been given a sample. You have been given a sample, right? You have
Yeah.
been given a sample. You don't know what functional group is present in the given sample. So you use Brady's reagent and you get the positive result. So can you tell particularly al is present or particularly on is present? Do you understand? my question?
If it's got an OH group.
Yeah, so al means we should have this kind of, right, and on mean carbonyl group like this, right? So either this or this may be present, but if you want to particularly test if al or on is present, you have to use the previous reagents, right? But Brady will give the positive result for both al and on. Okay, is that clear? Is that
Yeah.
clear? And the observation, right? What would be the observation? The observation would be an yellow color precipitate. What's that? An yellow color
Yellow
precipitate,
color precipitate.
right? So observation will be an yellow color precipitate. And one more thing, when we are performing experiments, along with this 2,4 DNPH, we have to use alcohol and dilute H2SO4 also, right? Alcohol plus dil H2SO4, right? So the combination of 2,4 DNPH, alcohol and dilute sulfuric acid is called Brady's reagent, right? So this is practical aspect, right? So in the laboratory 2,4 DNPH is present, available, and along with that we have to use alcohol and sulfuric acid also, and the combination of these three substances is called Brady's reagent. Okay, right. Now
Okay.
if you look at the observation, what would be the observation? The observation would be yellow color, yellow PPT, yellow PPT. Okay, now we will look at the reaction mechanism, right? Okay, so this is how the reaction will happen, right? So the reaction we have to discuss for al and on separately. We have to discuss for al and on separately. For al, now we will take CH3, C double bond O, H, right? And let's say we put 2,4 DNPH. So 2,4 DNPH will appear like this, right? So let's say we have NH, NH2, right? NH, NH2, and here we have NO2 group. Here also we have NO2 group, right? Now what will happen? This H is acidic. This H is acidic. So this H and this H are acidic. So they will remove, and along with this oxygen, they will form H2O, right? So here what
Yeah.
will happen? So this double bond, right? So you can see this double bond and this double bond will come and join with this carbon. So can you try to draw the structure of the yield?
Okay. So third of four.
Around the carbon there should be 4 bonds, right? But
Yeah.
the oxygen has taken the 2 bonds and combined with the removed
Hydrogen.
hydrogen to form water. So around the nitrogen in the 2 comma 4 DNPH, we have 2 remaining bonds. So they will come and
And
join
the
with
carbon
carbon.
also needs 2 bonds. Yeah, okay.
Yeah, very simple. Can you try?
So is it just oh wait, whoops. 6 sides. So I'll go like that, 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 and then NH, NO2, NO2, and then it will. So you will have 2 here initially, but because those 2 are gone, the carbon will bond here, and then you'll have a H and a CH3.
Very good. That's very simple, right? So this is how
Yeah.
it will appear. So give me a sec. So this will be the output, right? NH double bond NC CH3 hydride, and here we have NO2, here also we have NO2, and the same thing will happen for on also, right? So I don't want to actually explain, but along with that you have to write these things also. What are they? Plus alcohol, plus alcohol plus dilute H2SO4. Now we will explore how this reaction will happen for on, right? So on, we will take C double bond O CH3, and we put 2 comma 4 DNPH and alcohol and H2SO4, right? So you can predict it, right? So how will it appear? The same thing, right? So here NO2, here NO2, here we have NH, right? N and double bond C, CH3, very simple,
CH3.
right? Very simple. Okay. Right, so we will now move to the next one, right? That will be Lucas reagent, right? Again and again I have to add new page, I think. Right, so the fifth one, not fifth one, I think the fourth one, right? Fourth one or fifth one? Fifth one, right? So the fifth one, Lucas reagent. This is very important and famous reagent, especially applied for alcohols, right? So far we have discussed the reagent for aldehyde and ketones, but now we will move to the reagents that can be used to detect aldehydes. I'm sorry, what's that? Alcohols, right?
Yeah.
So this is the name, right? This is a name, and the chemical substances that involve in Lucas reagent will be zinc chloride, ZnCl2 plus concentrated HCl. Okay. Now here this ZnCl2 is a Okay, so here this ZnCl2 will act as a catalyst, right? So this
Yeah.
will act as a catalyst, and this concentrated HCl will be the what do you call the reagent, right? Or reactant, we can say reactant, right? Reactant, right? So here this we use this zinc chloride for boosting the reaction, but the reactant will be the HCl. Why? Because OH group is going to be replaced by Cl groups ultimately, right? Okay, so Lucas, right, so basically this Lucas reacts with alcohol only, right? Alcohol only, this react. Okay, so alcohols undergo reaction with Lucas reagent. Okay, now what will happen? So in alcohol we have OH, and when we administer this alcohol with Lucas reagent, it will become Cl, because why? OH group is going to be replaced by chlorine, right? Chlorine. Now we can classify alcohols into 3 categories, right? So did I teach you about the classification of alcohols when I taught you the basic concepts of organic chemistry?
I think so.
Can you recall?
It was primary, secondary, and tertiary.
Very good, right? So now we have primary, secondary, and tertiary, right? We can denote
Yeah.
this way. So primary, right? Can you try to draw the structures of primary, secondary, and tertiary alcohols?
Sorry.
Can you try to draw the what do you call the structure, typical structure of these alcohols? The general form.
Okay.
So we classify
Oh, wait.
alcohols depending on the
Okay,
number of
so-
carbon, number of hydrogens attached to the carbon
Yeah.
that is attached to OH group, right?
Yes. So if it's 1, there will only be 1. So we'll go COA. And then have to have a H here. And then we can have a double bond here. Oh, I don't have space. Is that correct? First one?
Yeah, wait.
Is the first one correct, right?
Yeah. So what is this?
It is ethanol. No, it's not ethanol. It is
Is
what's
this
it
a
called?
double bond?
Yeah.
Oh,
So it's not
not,
ethane.
right?
It is what's it called?
Okay.
Yeah.
So now this is the okay. Can you erase it?
Yeah.
Okay. So there will be a carbon, right? So to the carbon we have OH, and we have only one carbon, but to this carbon we have 2 hydrogen attached, and this is called primary alcohol. And if you have only one hydrogen attached to this carbon, that is called secondary alcohol. This is called secondary alcohol, right? Only one hydrogen. If we have no hydrogen attached to the carbon, then it will be called tertiary alcohol, right? So carbon, OH, here C, here also C, in alkyl group, right? In alkyl group or any other group, right? C, it can be anything, but it shouldn't be a hydrogen. It shouldn't contain. I mean, oh, this is not O, this is OH. Right? This is OH, right? Okay, so
Okay.
this is the general form of the alcohols, right? Okay,
Yeah.
now when we administer these structures or these alcohols with Lucas reagent, right? So primary alcohol will give you kind of its yield is very negligible, right? So it will not react at all, we can even say, but there will be some observation of yellow color, kind of small yellow color one, right? Now if you consider the order of the reaction, tertiary alcohol will give you instant result, right? So we can say this will give you instant result, right? So this is result is negligible, and this is kind of slow reaction, right? Slow reaction. So in this direction, what happens? The reactivity increases. Okay. So what would be the yield? Simply, if you use primary alcohol, if we use COH, we have CHH. Simply, instead of this OH, we will have Cl. That's all, right? CH, and the same thing, right? Instead of this, we will have Cl. Instead of this, we will have Cl. All alcohols will give the result to Lucas reagent, but the tertiary alcohol will give the instant result. Instant result means now the primary alcohol will not give you the result, right? So it will take more time and the result will be negligible, right? But for the secondary alcohol, it will give you the result, right? It will give you the result, but the reaction will be very slow. But for tertiary alcohol, once you have administered the Lucas reagent, it will give you the instant result. Okay. So the reactivity series increases in the order of primary, secondary, and tertiary alcohols.
Tertiary.
Okay.
Okay.
Now we will move to the next topic, that will be our oxidation tools, right? Oxidation tools. Before that, you already sent me some note, right? Do you have the note? I think this one.
Yes. Wait, which one did I talk about?
I think it's loading. So after finishing the class, you better check if you can access the things that I wrote today, right?
Okay.
Give me a sec, it's loading. So what type of reaction is this? So we already discussed what is this? Redox reaction, right? So this is called substitution reaction, right? Substitution.
Okay.
Right? Substitution reaction, right? You can write these things, right? So there is nothing, right? So this is called substitution reaction. Why? Because Cl minus is substituted instead of OH, right? So this is called substitution reaction. So this is neither redox reaction or any other reaction, right? So substitution reaction.
Hello? Hello?
Okay. Uh, right. So this is the note that you sent, right? Are you studying
Yes.
this note?
No, I'm using different notes, but these notes are
Hello?
very
Am I audible?
useful as well.
Oh, I'm sorry. Were you speaking anything?
No, not before.
So you have sent me this note, right? Um, is this the note that you have to study or follow?
It's similar. I'm using a different set of notes,
Mm-hmm.
but
There are
was-
conversions also, right?
I am also. Sorry?
There are conversions also. The same reaction pathway can be used to create several different products. Okay. Yeah. Anyways, the organic chemistry you have to study the basics, right?
Yeah.
Yeah. So we will study in this manner. If we study here and there, then sometimes we might skip something, right? So we better follow one thing, right? So we will follow the Sri Lankan curriculum because Sri Lankan curriculum is the best curriculum in the entire world, right?
Okay.
Even though it takes time to complete the curriculum or to complete the A levels, it has been properly designed, right? If you study
Yes.
according to Sri Lankan curriculum, you can get a complete understanding of organic chemistry. Not only organic chemistry, um, that is the best curriculum in the entire world, right? Because so the country to country the curriculum is different, but they don't follow. In other countries, in Sri Lanka, we follow a certain rule, right? A certain rule means we follow a certain order. But in other countries, I don't feel such or a good order is followed, right?
Okay.
Otherwise, I should have the experience in teaching your curriculum, right? That's the issue. So
Yeah.
we will go with the Sri Lankan curriculum. That doesn't matter. Anyways, we will have to obtain the complete understanding of organic chemistry. Here also we can classify amide, right? So primary
Yeah.
amide, secondary amide, tertiary amide. We already
Is
discussed
it only for amides and alcohols, or is it for everything
I'm
that you
sorry?
can do the primary, secondary, and tertiary?
Yeah, not only for alcohol, we can give to other functional groups also, similar to alcohols, right? So now if you see, in primary amide we have 2 hydrogen, in secondary amide we have 1 hydrogen, but in tertiary amide we don't have any hydrogen attached to nitrogen, right?
It's the reverse of the primary alcohols.
Yeah.
Okay.
Did we study isomerism? I think yes, right?
Yeah. I don't think so. No.
We discussed isomerism already, right?
Yeah. Isomerism. Isomers.
Chain isomers. Yeah, we studied about.
Oh wait, yeah,
Yeah,
I remember
yeah,
this.
okay.
Yeah.
Right.
And then there's the special rule for it as well, right?
Yeah.
Defining the abundance of it and all. Yes.
Okay, now we'll move to our next one. That will be oxidizing tools, right? Right. This is also very important. Okay. oxidizing tools. So recently, no, recently also I wrote an advanced organic chemistry module in the university, right? So you can see this one, right? So this is advanced organic synthesis, right? So this is my lecture note 1. You can study all these things, right? So now you can see organic synthesis, right? So I'm just teaching, right? Organic synthesis. What is organic synthesis? Organic synthesis.
Construction of
Right?
organic compounds.
We are
using
going to
specific-
form organic compounds, right? So you can see the definition. Organic synthesis is a special branch of chemistry that is focused on construction of organic compounds using specific organic reactions. So the core concept in organic chemistry is learning organic reactions. And for performing organic reaction, you should be fluent with the organic reagents. Then only you will be able to make conversion. For example, you
Yeah.
see here. Oh. The screen is annoying me. Okay. So here, right? So reasons for synthesizing organic compounds, right? So we've already now, even though you don't take this to your brain, you just have some idea when you study your further studies. This might be coming to your mind, right? So I have learned this somewhere, right? Like that, right? So reasons for synthesizing organic compounds. Nobody will ask you this question in your examination, but we should know, right? So you should have some
Yeah.
kind of intuition. So proof of structures of natural compound by putting it together form simpler molecules, right? So these are the reasons why we need to synthesize organic compounds. So for your additional reading or for additional knowledge, you can see not only in medical industry, it is useful in polymers, dyes, right? So pharmaceuticals, right? So majorly organic chemistry is used in pharmaceuticals or to produce medicines, right? Okay. Even for synthesizing vaccines, nothing, right? So inside organic chemical reactions are happening in the invention of vaccines or medicines, right? Okay. Now this is the have you heard about salbutamol?
No.
Okay, so salbutamol is the medicine used for treating asthma, right? So what is asthma?
It is a medical condition where individuals struggle to breathe.
Okay, so you have difficulties in breathing, right? So
Yeah.
this is the structure of salbutamol, right? So now this is a complex chemical, complex organic compound. For synthesizing it, we are going to start from something called substrate. What do you call substrate? So substrate is the chemical substance that we start the organic synthesis with, right? So how do you call this? Now this we have to start that. Now, so this is the procedure for synthesizing salbutamol. Don't be afraid of this. You don't want to actually be afraid of this. This is very simple, right? But even though it might loom large you, right? So because there are big structures, it might loom large you, but there is nothing difficult. This is very simple, right? So we have to start it with salicylic acid, and this salicylic acid is called substrate, right? What is substrate? For example, we start a synthesis from something, right? That one is called substrate, and these are called organic reagents, right? And ultimately this is called product, right? So finally the salbutamol is called product, and these are called intermediates, right? What are they? Intermediates. Intermediate mean the substances forming in between the reaction, right? So there are terminologies, right? That's all. Okay, now we have to study all these things. We have to study the function of AC2O, for what are the conversion, what it will do. We have to study all of them, right? There are many things, but little by little we have to study, right? Okay, right. And then so here you can see oxidations, right? So here oxidation, right? So we are going to learn about the oxidation tools, but I'm going to introduce the advanced concept first. After that I will go to the basics, right? So oxidation means what?
Okay.
Okay, so oxidation, the basic idea of oxidation and reduction according to your knowledge in inorganic chemistry. You have already studied oxidation reaction and reduction reaction in organic chemistry also. So
Yeah.
what is oxidation and what is reduction?
Oxidation is the loss of electrons, while reduction is the gaining of electrons.
Yeah, so loss of electron is oxidation and gaining of electron is reduction, right? That is very simple,
Yeah.
right? Okay, and in other words, we can say in context of electrons, we can say if electrons are lost, then oxidation occurs, and if electrons are gained, reduction occurs. Similarly, oxidation may happen when loss of H2 or gain of oxygen or halogen happen as well, right? For example, let's say now you see, for example, right. So if hydrogen is removed or if hydrogen is lost, then we can say oxidation happens, right? So similarly, earlier
Yeah.
also we discussed, right? So we had something like this, CH3 C double bond OH, right? And it produced CH3, I'm sorry, we discussed this one for what do you call, Feeling solution, I think, right? So CH3 C double bond O minus NH4 plus, right? Now how do we
Yeah.
form this O minus? By releasing this H plus, and here the oxidation number is +1, here +3. So what has happened? By releasing, if a hydrogen is lost, then oxidation happens, right? So in organic chemistry, we will not be talking about the loss of electrons, we will be talking about the loss of hydrogen or gain of oxygen, right? Do you understand that?
Yeah.
Okay. Or sometimes we might gain halogens also, and the vice versa will be the reduction, gain of hydrogen or loss of H minus or oxygen or halogen, anything, right? So this is the basic idea, right? So in inorganic chemistry, if electrons are lost or gained, they are called oxidation and reduction respectively, but here we will be talking about the loss or gain of hydrogen, oxygen or halogen, right? This is the thing.
Okay.
Right, so there are some other concepts. Okay. Now, okay, so you got this point, right? So we will go to our
Yeah.
basic. I will try to share this one also, right? I will try to share this one also. Okay, so the next topic is what? Oxidation tools. Right? Right? So the symbol, right?
Okay.
So we use a symbol. I don't know if you guys use this symbol. Here we use this kind of symbol for referring to oxidation tools, right? So
Okay.
here we have two types of oxidation tool, right? So strong oxidation tool, strong oxidizing tools, right? And then weak, weak, W-E-A-K-O, weak, right? What is the spelling? Weak, right? Am I correct? Is the spelling correct for weak?
Alright.
Is the spelling correct for weak?
Yeah.
That weak is the weak, okay. Weak oxidizing tools, right? Okay, so we have some examples. So particularly we are going to be talking about three types of strong oxidizing tools, right? So the first one is acidic potassium permanganate, H plus MnO4 minus, potassium permanganate, right? And acidic dichromate, Cr2O7 2 minus, right? And then basic OH minus MnO4 minus, basic permanganate, right? MnO4 minus. Okay. And under weak oxidizing tools, we have PCC. What is that? Pyridinium chlorochromate. How do we say that? Now you see,
Can
in
you repeat
organic
that?
chemistry, we will be having long names, right? So for our convenience,
Yeah.
we will be using some contracted form, right? Contracted form, like
Okay.
now earlier also for Brady's reagent we use 2,4 DNPH for referring to 2,4 dinitrophenylhydrazine, right? So here this is called
Yeah.
pyridinium chlorochromate. So we abbreviate it as PCC, right? So let me write it. Pyridinium chlorochromate. Okay, right. So we have to study one by one. Okay. Okay, so now we will first talk about the strong oxidation agent, right? Strong oxidizing tools. Right? Under that, we are going to first talk about H plus MnO4 minus. H plus MnO4 minus, right? So here, H plus MnO4 minus can react with alcohol, alkene, alkyne, and benzene, right? So the first point is this can oxidize alcohol, alkene. Alkene means double bond, alkyne triple bond, alkyne and benzene, right? So directly what do you call this, acidic permanganate can oxidize these functional groups, right? Benzene. Okay, right.
Okay.
It's not nice, right? Let me go to the new page. H plus MnO4 minus, right? So this is the first one. Okay. So here this can react with, I'm writing over here, right? So alcohol, alkyne, alkene, and benzene, right? Benzene.
Yeah.
Okay. Now we are not going to talk about how this happens for alkyne and alkene because they are not popular, but we will be talking how the mechanism of the reaction will occur for the case of alcohols. Okay, right. Now whenever we talk about alcohols in organic chemistry, we have to think about the three categories. What are the three categories? Primary alcohol, secondary alcohol, and
Secondary and
tertiary
tertiary.
alcohol. Okay, right. So we will talk about the primary alcohol. Okay, so let's say we have COH, hydrogen, and it can be anything. There can be anything, right? So we put H plus MnO4 minus. H plus MnO4 minus. So when a primary alcohol is administered with what do you call this, acidic permanganate, it will produce oic acid. It will produce oic acid. So it will become C. There will be no change here, but this one, right? So this entire thing will become C double bond OH, right? So C double bond OH, C double bond OH, and this is called oic acid. But there will be an intermediate also, but it will happen in two steps, right? So if you perform this test in the laboratory, ultimately you will get oic acid, but in the system literally it is happening in two steps. It is happening in two steps. It produces an intermediate yield also, and that intermediate yield will be aldehyde, right? So that now it happens in two. This is a two-step reaction, right? So some reactions happen in two step, right? So this is also a two-step reaction. So here first it will produce C double bond OH, right? So aldehyde, and under this circumstance, when we apply or in acidic permanganate medium, this aldehyde is not stable. This is not stable, right? So this is not stable, not stable. Instantly it will become oic acid. So it is happening in two-step reaction. Okay, is that clear? But when you administer alcohol with acidic permanganate, it will anyhow produce oic acid, but it happens in two-step reactions, right? Okay. Now, are you clear with this?
Yeah.
For example, you can simply say an example. Let's say we have CH3, C double bond. I'm sorry. CH3, OH, H, and here also H, right? So CH2, CH3, CH, okay, OH, right? So we put H plus MnO4 minus. So what will it produce? We will produce CH3, C double bond OH, but initially it should have produced CH3, I'm sorry, here OH, CH3, C double bond OH, right? So it should have produced Al, and then Al should have been transformed to oic acid. Okay, this is a simple example. Okay, right, and then we will go to our secondary. Oh, it's not moving, right? Right, now the secondary alcohol, right? So the secondary alcohol, we will have COH, here C, here C, here H, right? So now if you put H plus MnO4 minus, it will produce on. It will produce on. So what will happen is this system will convert to C double bond O. There will be no change in this carbon and in this carbon. So these two carbons come here. So this is how you have to study organic chemistry. When we put an reagent, what happens to the structure? What happens to the structure? You cannot blindly memorize. You have to trickily memorize, or you have to trickily remember what is happening. Okay, so you have to use a lot of tricks here. Otherwise, you will be flown off. Right?
Yeah.
Okay. So here, what is happening? This system converts to this. This becomes this, and there will be no change in this carbon and in this carbon here. Right? This is the thing. For example, this is very simple, right? So for example, if you put CH3, COH, CH, CH3, and you put H plus MnO4 minus, can you try to predict the yield?
You will get, so the H plus will go, and then you'll get an OH group. I'm not sure.
Give me a sec. Okay, so here, right, so how will the yield appear? Now?
I'm not sure.
You're not sure, okay. Okay. Right, so you see here, there will be no change in the CH3 and in the CH3. But this system will become C double bond O. So this C double bond O and around this carbon CH3 and around this carbon also CH3. Very simple, yeah?
Yeah.
Okay. Now I will give you another. Right. So what about this one? We have CH3, CH2, C double COH, CH, CH3. If you put H plus MnO4 minus, can you try to figure out the yield? What's the yield? You can sketch on the screen itself.
Sorry?
You can sketch on the screen itself.
Yeah.
On the phone. The body can never. I don't know. Yeah, you can try to predict the yield.
I'm not sure what the yield would look like.
Oh, okay, just look at the previous case. What has
Yeah.
happened, right? What has happened, right? That's my pen. Oh, yeah. So here, if you have carbon, right? So this is a secondary alcohol, right? This is a secondary alcohol. So the secondary alcohol should become a carbonyl group, right? So here, this will become C double bond O, and we have to just draw these two, right? So CH2, CH3, and here CH3. Very simple. Okay. Is that clear? No
Okay.
matter what
So,
we have.
Give me 1 second.
Yeah.
So, the, yeah, I'm just. So, Oh, so the H's just go out. So you just
Yeah,
get
yeah.
rid of the
Now here
hydrogen.
I have drawn
Okay.
this H separately, but here I have used the condensed structure, right? So it
Yeah,
doesn't
okay.
matter. First you have to figure out whether it's secondary alcohol or primary alcohol, and based on that you can draw the what do you call this, yield. Okay. Now the third one, actually there will be no. We don't want to actually study about the tertiary alcohol. So the tertiary alcohols will not undergo any kind of reaction with oxidation reagents, right? So for tertiary there will be no yield, right? So for tertiary, no response or no result, okay? No reaction will happen.
Okay.
No reaction will happen. Okay. And then the same thing, right? So we use I'm unable to expand the page, I don't know why. Anyways, let me insert another page. Okay. Right. So the next thing, right? So the continuity of our H plus MnO4 minus. Okay. Right. Now let's say we have a benzene ring, right? Benzene ring,
Yeah.
and to the benzene ring we have carbon, and to the carbon we should have at least one hydrogen attached to this, right? At least one hydrogen. But here this may be anything. It may be hydrogen or any other group. Here also it might be any other group. But to the benzene, to the carbon attached to the benzene, there should be at least one hydrogen attached to it, right? And for this, if you put H plus
Okay.
MnO4 minus, it will produce oic acid, benzoic acid. It will produce
Okay.
benzoic acid, C double bond O H, right? So C double bond O H, sorry, benzoic acid, right? Benzoic acid means, I'm sorry, C double bond O OH. I'm sorry, C double bond O OH. So if you have this type of structure, so you should remember this point, right? To the benzene, to the carb, oh no, for example, we have this kind of structure, right? We have a benzene.
Yeah.
To the benzene we have carbon, and to that carbon there should be at least one hydrogen. There should be at least one hydrogen. And if you administer it with acidic permanganate, it will produce benzoic acid. Okay, shall we do some examples for this?
Okay.
Right, so examples, right? So I will draw some pictures, you can try to predict it, right? We have benzene CH3, and the second one we have benzene CH2 CH2 CH3, third one, right? So these are the examples. Benzene, we have CH3 CH3 CH, and fourth one benzene CH3 CH3 CH3. Okay, can you try to predict the yields? We put
Sorry.
acidic permanganate for all these substrates. What
Yeah.
will be the yields? Can you try to predict the yields? We put acidic MnO4 minus, here also acidic MnO4 minus. For everything we put acidic MnO4 minus because we are studying under acidic MnO4 minus. So can you try to predict the yields based on the theory that I taught you now?
So the first one will just be the same as the most recent example,
Yeah,
right?
this one, right? The same thing.
Yeah.
Benzoic acid. And the second one?
And then second one, so you get you will have it'll be you'll get rid of the CH3 and it'll be replaced by a C double bond OH.
You don't want to think like that. Now you see, CH2 CH3 means I told you to the carbon atom directly attached to the benzene ring. If we have at least one hydrogen, it will produce what? Benzoic acid, right? So here, this is the carbon atom directly attached to the benzene ring, and to that atom we have two hydrogens, right? Two hydrogens, right? Do we have two hydrogens? Okay, how can you expand this structure? You can expand this structure like this, right? I'm expanding the structure of this one. I'm not organized. I'm not writing in an organized manner. I can simply expand this as benzene C H H CH2 CH3, right? Now you see, to this carbon we have two hydrogens, so we have fulfilled the requirement, so it will produce a benzoic acid. It will produce benzoic acid, right?
Yeah.
Is that clear? And what about the third one?
Third one, you get let's see, CH. You'll have a benzoic acid. And
Yeah,
then
definitely you will have benzoic acid. Why? To the carbon atom attached to the benzene ring, we have one hydrogen. At least one hydrogen should be there, right? So it will also
Yeah.
produce benzoic acid. And what about the fourth one?
Fourth one, same.
The same? Yeah. So it also will produce benzene C double bond OH, right? Is that
Yeah.
okay?
Yeah.
Is this correct? Is the fourth one correct?
Sorry?
Is the fourth one correct?
I believe so.
Why?
Well,
Can you give me some reasons for saying, for why you say this is correct?
because
What's the theory?
Orbit.
What's the theory?
the theory is that you'll get rid of one of the oxygen and the OH group will bond onto a carbon.
Yeah. What's the requirement for the substrate to form benzoic acid when we administer it with acidic MnO4 minus to the carbon atom directly attached to the benzene ring? We should have at least one hydrogen. Now you see, first we have to identify the carbon atom that is attached to the benzene ring. What is that? This one, right? To this one. To this carbon atom, do we have any hydrogen that is directly attached? To this carbon atom, do we have any hydrogen atom?
Not directly attached. No.
Not direct. There are hydrogen atoms, but to the next adjacent carbons, right? To the adjacent carbon only we have hydrogen, but to that carbon we don't have any hydrogen. So this will not produce benzoic acid. This will not produce benzoic acid. Do you understand?
Okay.
Okay.
Yeah.
So this will not produce benzoic acid. This is wrong. This will not produce. There will be no reaction here. Okay.
Okay.
What's the reason? Because to the carbon atom,
Yeah.
you can realize the reason, right? Okay.
Yeah.
Now we'll move to the next one, that will be acidic dichromate. What's that? Acidic dichromate. Now we have two more things. The same thing will happen, right? So these also can react with alkene, alkane and alcohol, and the reactions will be similar to the previous reagent. We don't want to actually study about that, I think, right? Okay. But there's the same thing. Whether you put acidic MnO4 minus or acidic dichromate, the same yield, the same reaction. But the reaction might be slightly different, which means, for example, if it is an oxidation reaction, okay, for example, now you see here when we use MnO4 minus, here alcohol is oxidized to oic acid, so MnO4 minus will reduce to Mn2 plus, right? Mn2 plus, right? Because this is the oxidation state of Mn is +7. So when this one is oxidized, oxidation and reduction should happen simultaneously, right? They are coupled together, right? When oxidation happens, the other substance should be reduced. Then only we can establish a neutral charge in the reaction system. Okay. So
Okay.
MnO4 minus will be reduced to Mn2 plus. But when we use dichromate, then again it will be reduced to chromium 3 plus, and the colors will be different. That's the only thing. But we are not going to be interested in inorganic chemistry, right? So I didn't tell anything about the reduction of MnO4 minus because we are studying organic chemistry, right? But you should have already studied about inorganic chemistry, right? MnO4 minus, when it is reduced, it will become Mn2 plus. These things we are not interested in here, right? But we are interested what will happen to the organic compound only. Okay, right? So here we will have to study about now the same thing, right? So H plus Cr2 O7 2 minus, it can oxidize the following functional groups, right? So basically alcohol, right? So we have to oxidize alcohol, alkene and alkyne, but generally this H plus, this oxidizing reagent is not strong enough to oxidize ON, right? ON cannot be oxidized using acidic dichromate because that is not strong enough to oxidize ketones, right? Do you understand?
Okay.
Okay. Now then with the third one also similar, but it has some other functions also, right? That will be basic MnO4 minus, right? And this basic MnO4 minus is called Bayes test, right? Bayes test. Okay. Now this Bayes test is what do you call this? This can give you positive results only to the alkenes, only, right? Alkenes. It will, how can I say? It will give positive output to alkenes, right? So for example, let's say we have C double bond C. Here we can have anything. We can have anything. So if you put cold and diluted OH minus, right? So here OH minus is medium. OH minus is medium. MnO4 minus is the reactant, and we already discussed in Lucas reagent. Zinc chloride is catalyst, right? Catalyst. Here OH minus is not catalyst, it is medium. You should be able to understand the differences between reactant, medium and catalyst, right? Medium, catalyst. They are not same. They are the different things, right? Can you be able to understand the differences between reactant? Reactant will directly involve in the transformation, but medium is kind of, what is medium? For example, aquatic medium, right? So that is the place or the surface or something that the reaction is happening on, right? Do you understand? The medium. And catalyst, that is different. That will increase the reactivity. That will increase the reactivity. So here OH minus is just medium, right? And the condition for the medium is it should be cold. It shouldn't be hot. And we should use diluted base, diluted OH minus. It can be anything, NaOH or KOH, anything. But since NaOH is cheaply available in the laboratory, we will generally use NaOH. but we can use any base substances. Okay, right. And if you put MnO4 minus, it can be sodium, MnO4 minus, potassium permanganate or sodium permanganate, anything, right? Anything according to the availability. So what will happen is here this pi bond will break and OH will be added. So this is called addition reaction. So we will have to study about the categories of organic reaction. We have radical reactions, SN2 reaction, SN1 reaction, right? Substitution, nucleophilic substitution, and we have electrophilic substitution, right? Electrophilic addition, electrophilic substitution. We have 6 types of organic reactions, right? So we'll study about that later, but now you just understand this pi bond will break, and here you see we have sigma bond. Breaking the sigma bond might be difficult, right? So here, right, here we have, right. So now what will happen? I'm using a different color. This pi bond will break and OH will be added to the both carbons. OH will be added. Okay, this is what will happen. Now we will do some we will discuss an example, right? So let's say we have this compound, right? So CH3 CH double bond CH2. So we administer this particular compound with cold diluted OH minus with MnO4 minus. Okay, so can you try to predict the yield?
So
now you see, if it is
that,
difficult, you better expand the structure and then think.
Okay. So you have to, okay. So you have that, but then you also have a hydrogen bond directly attached to it.
Yeah, you can draw the structure on the screen itself.
So if you have a hydrogen directly attached to one of the carbon ones, you
I'm sorry?
I'm just thinking, sorry.
Okay.
But then you still have a hydrogen attached to it.
And while you are drawing benzene, sometimes you might forget to put the circle inside the hexagonal shape, right? So you shouldn't do that. You have to draw a hexagonal shape, and then inside the hexagon you have to draw that circle also, right? So that is the structure of benzene. Sometimes in some examinations they might reduce marks for that kind of mistakes also. Okay, that's fine, but no, actually this is okay, but for this structure you are supposed to write the yield, right? So this is not correct actually. Can you think again? So here it may be anything, but for this case we have something, right? So here we have H, and here we have CH3, and here we have H, and here also we have H. So here we are supposed to put H, here CH3, here H, and here H. So this is the accepted answer, right? This is the accepted answer. Do you understand that? Is that okay?
Yeah.
Okay. Right, now we will move to the next one, that will be weak oxidizing tools, right? So The next one, weak oxidizing tool. So here we will talk about PCC only, right? PCC means pyridinium chlorochromate, right? Pyridinium chlorochromate. So the same thing, right? So we discuss the oxidation for alcohols, right? So primary alcohol, secondary alcohol, and tertiary alcohol. So oxidizing tool, but weak means now a strong oxidizing tool can oxidize primary alcohol till oic acid. But weak oxidizing tools are not that much strong enough to oxidize primary alcohol to oic acid. It will oxidize only till aldehyde, right? So here we have COH, CH. If you put PCC, it will become C double bond OH and here carbon. So this structure converts to C double bond OH, right? So primary alcohol is converted to aldehyde. And the secondary alcohol, similar to the strong oxidizing tools, it also will become on, right? Here only the change. But secondary alcohol, COH, CCH, if you put PCC, it will become C double bond O. Here this becomes C double bond O, and this C is here and this C is here. And for tertiary alcohol, no reaction. Okay. Should we do examples also? I think not necessary. Yeah. Now the next one, right? So if you go to the list, right, we have completed this tolerance reagent, all these things, right? We have discussed oxidizing tools. Now we will move to reducing tools, right? So the opposite of oxidizing tools. Reducing tools, right? So under reducing tools, we have some categories, right? So we are going to talk, we have some list, right? So we have actually 5, 3, 4, 5. These are very famous reducing tools, right? Right. Zinc amalgam concentrated HCl, right? So first one, zinc amalgam and concentrated HCl. The first one, zinc amalgam. Okay. And then H2PT, right? So this is very famous. This H2PT is very famous. So instead of PT, we can use palladium and nickel also. But here again, this PT is catalyst, H2 is the reactant. And then lithium aluminium hydride. What is that? Lithium aluminium hydride. And then sodium boron hydride. And here we should have aquatic medium, right? H2O should be there. And then finally we should study about sodium ethanol. This is not that much important, right? But these three are very important. Okay, right. Now first let's discuss the first one, zinc amalgam concentrated HCl, right? Zinc amalgam concentrated HCl. Okay, right. So for this reducing tool, Al and On will answer. Only Al and All, right? Only Al and All. Okay, right. So here, right. So now you see here for Al, for Al O, right. So now I'm going to draw a combined general form of Al and On, right? So we can draw like this: C double bond O. Here we can have either hydrogen or carbon, Here also we can have either hydrogen or carbon. It doesn't matter what we have here. If you put zinc, amalgam, concentrated HCl, what will happen is this CO will become CH2, right? So this oxygen will disappear and it will be converted to H2, and here we will have carbon or hydrogen, whatever the group that we have here, right? Right?
Okay.
So carbonyl will be converted to CH2 group. That's all, right? That's all. Now if you look at some examples, you can easily understand, right? Examples. Now for example, can you try to do them? The first and second. CH3 C double bond O H, and again CH3 CH2 C double bond O CH3. We put zinc, amalgam, concentrated HCl. Here also we put zinc, amalgam, concentrated HCl. Okay, can you try to predict the yields? For the next fortnight, I will be free during the morning time. If you are okay, you can request me to have additional sessions for the missed sessions, right?
Okay. I will let you know.
Are you trying the questions?
Yes, I'm just thinking. Because if you have that, then you'll end up with Is that
Yeah,
correct?
yeah, very good. And then the second one.
So when you break that bond, you'll get your CH2, and then you keep your CH3 here,
Mm-hmm.
and here you keep your stuff. Is that right?
Yeah, and when you're drawing this one, you better now to this one, this CH2 should be attached, right? CH2 CH3, like that you have to draw,
Oh
right?
yeah, okay.
Okay, and then we have to study what's the next one? H2PT, right? So H2PT, yeah. Okay, so I think it's enough for today. H2PT we will discuss in the next class, right? So
Okay.
if you have any questions in the concepts that we studied today, you can ask. Otherwise, we can wind up the session.
No, I don't have any questions.
Okay. So if you have any free time, you can let me know in advance for the next fortnight only, right?
Yeah, okay.
After that, I will be a bit busy. So we can, if you are mutually, I will be always free during the morning time. You have to at least tell me during the, before,
Yeah.
during night time, right? So then only.
Yeah.
Okay. Otherwise, sometimes I may sleep, right? That's the issue.
Yeah.
So okay, that's all. We can meet in the next class.